Good morning. I hope we're all well. I hope we had a great weekend. Just getting things set up here. It was nice this weekend. I was able to kind of get away, unplugged. I was up in Lake Arrowhead in my mother in law's cabin, and it was really nice. But I think that, like the guest bed is like a bajillion years old. And so, like the sleep-wise, just doesn't happen very well. Like, oh man, I feel like I didn't get any sleep. There are my dogs barking. Let me text my wife about it real quick. All right. There we go. So I'm hoping that we had a chance to take a look at this, and we're just pretty much going to move through the rest of the document, and then that'll give you guys Tuesday and Wednesday to get everything in. Today on Google Classroom, the assignment will be open for you to be able to submit everything. So that's going to be good. But let's look at Section M. Section M is kind of all over the place. It really is. There's a few of the logs. So like these log problems here, the exponential problems. If you want to skip that, that's okay. Because we didn't really go over it in class. We didn't have the time to go over it in class, so I understand if we didn't, if we're just not getting it. But those were the 100 section that were online. So if you want to take a look at them, hopefully we were able to take a look at them. If you didn't, my recommendation is to take a look at them over the break before we move into calculus. Unfortunately, logs will be a small part of calculus. But are there any of these in particular that you would like me to go over? Okay. Well, I'll just kind of pick a few, like number 3. Says use the properties of logarithms to find what log base 9 of 4 over 243 is. So it's telling us log 9 of 12 is A, log 9 of 8 is B, and log 9 of 5 is C. So what we need to do is we need to break this up into those different values. So, for example, this 243, what is divisible by 243? I think it's divisible by 9. If I can find my mouse and I can get my calculator out. So 243 divided by 9, I get 27. So I can break this up. I get log of 4 over, log base 9, of 4 over, and then I'm going to get 9 times 27, because 243 divided by 9 is 27. Now, because it says log 9 of 12, log 9 of 8, log 9 of 5, I want to try and break them into those. I want to break them into log 9 of 12 and log 9 of 8 and log 9 of 5. That's the goal. That's what I want to do. Let's see. What else can I do here? Okay, so the next one is, well, I do have a log 9. That's okay, since it's log base 9. That's fine. The 27, I can break it down again, so maybe we'll try and do that. So log base 9 of 4 over 9 times 9 times 3. Now for the 4, I don't really have anything that says log base 4, so I can multiply top and bottom by 3. Because now it's going to turn this 4 into a 12. So I'm going to get log base 9 of 12 over 9 times 9 times 9. So now that I've broken it up, I can actually rewrite this as addition and subtraction. So I get log base 9 of 12. Now since these are on the denominator, they're going to get minuses. So log base 9 of 9 minus log base 9 of 9 minus log base 9 of 9. I hope that didn't cut too much of it off. It didn't. Okay, good. Well, log base 9 of 12 is A. And then log base 9 of 9 is 1. So 1, 2, 3. So it'll be A minus 3. This one is a more difficult log problem, though. So if it's like, wait, what? Don't be too alarmed. Are there any other ones, like on section M? Like I said, because we didn't go over it, number 2 skip, 3 skip, 6 skip, 7 skip, 8 skip, 9 skip. This one you can plug into a graph. Okay, let's look at part N. So it says sketch the graph, find the domain and range. So the majority of these, so 1s through 6, those are just the parent graphs. And so we have to remember like what the shape looks like. For example, on number 3, I have 1 over x minus 2. So the parent graph, we have these asymptotes at y equals 0 and x equals 0. And then this is my h, so it's going to shift over 2 spaces. So this is going to move over 2. So if that's the case, and then my graphs, so then the domain would be everything but here. So negative infinity to 2, 2 to infinity. And then the range would be anywhere but here. So that would be from negative infinity to 0, from 0 to infinity. One and 2 are parabolas. That's the rational. Number 4 is a square root. Number 5 is exponential. Number 6 is absolute value. Let's look at a sine and cosine. So let's look at number 8. So I have negative 2 secant of 2x plus pi, and then plus 3. So it's secant. Secant in my brain, I need to think of it in terms of cosine for now. So that's going to be what the parent graph is. I have an amplitude of 2. I have a reflection. So that means that the red part is what it'll look like, because that flips down, that flips up, that flips down. So I should draw it with the shape of the red. I have a vertical shift, I have a horizontal shift, and I have a period change. So I take the 2x plus pi, and put that between 0 and 2 pi. So I'm going to minus pi. I get negative pi halves, because then I'm going to divide by 2 is less than or equal to positive pi halves. So then negative pi halves and positive pi halves. Add the ends, divide by 2, you get 0. Add the ends, divide by 2, you get negative pi fourths. Add the ends, divide by 2, you get positive pi fourths, since those values are in the middle. And so now I can draw my graph and start labeling it. So this is negative pi halves, negative pi fourths, 0, pi fourths, and pi halves. I have my vertical shift, so it's going to move up 3 spaces. Now from there, I should draw in what my parent graph is. So it starts here, crosses, and then it goes above, crosses, and then it goes back down. So I just drew that shape, but it's secant. So secant is going to be wherever it crosses the center line, you're going to get asymptotes. And then at the peaks, you're going to draw parabola-looking things that approach the asymptote. So that's the sketch of the graph. Now the domain, if we kind of look at the pattern here, and if I were to kind of keep going, it looks like every pi fourths, so 3 pi fourths, asymptote, and then pi, and then 5 pi fourths, asymptote, negative 3 pi fourths, asymptote. What we can do is we would just say, okay, it's this region here, it's this red part that don't have the asymptotes. Those are our solutions. So I'm going to put open circles where the asymptotes are. So we can do dot, 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 wow, dot, 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 from negative 3 pi fourths to negative pi fourths, union, negative pi fourths to pi fourths, union, and then just do another one. So it'd be from pi fourths to 3 pi fourths, and then dot, dot, dot. So we've established a pattern, and this would be the domain. And then the range for this one, it seems like there's a gap in between here to here. So there's no graph in between those values. So it'll be from negative infinity to negative 1, union, and then 1, 2, 3, 4, 5. And so then from 5 to infinity is the next value. Any questions on section N? Okay. So part O, we need to sketch a piecewise function. So to make that easier, I'm going to copy and paste in a graph. So it's going to be a little easier. Oh my gosh. Someone is charging $4.50 just for an image similar to this. That's crazy. $4.50. Oh my gosh. Like, you would think that that's just should be free. Okay. So, basically, this part right here, these are our boundaries. So -2 and 2 seems to be where everything is being broken up. So I'm just going to kind of draw in those boundaries. It kind of helps a little bit. I know that my graph, each graph is going to be different in those parts of the boundaries. So it's x squared where x is less than or equal to -2. So x squared looks like this, starts here, and I'm just going to sketch it in real quick, and then I'm going to erase it. So it's going to be right here. So it starts right here, and then, so it's going to be that part. And then on that line where the graph is, if it's equal to, you draw in a closed circle. If it doesn't equal it, you draw in an open circle. So because it equals it, I'm going to emphasize that it's a closed circle there. And then, ooh, but if I erase it, it's going to get rid of some of these other graph pieces. Okay, that's not too bad. All right. The next part is 3 minus x, and that's between -2 and +3. So my y-intercept there is going to be 3, and then it's going to have the slope of -1. So it's going to go down 1 over 1, down 1 over 1. Now, because those boundaries at -2 and +2, there's no equal to sign, so we're going to draw an open circle on those boundaries, and then we're going to connect them. And then at 4, that's where everything's, it's just y equals 4. It's equal to that, so I'm going to draw a closed circle there. And then whenever it's y equals, it's always a straight line. The domain and range. My domain, it seems like it's going on forever this way. It's going on forever this way. So it should be, and there's no gaps where these are at. It seems like if wherever I have an open circle, there's also a closed circle. So my domain was going to be from -infinity to +infinity. My range, it looks like the lowest value is right here at -1, and it doesn't include it. So at -1, it's going to have a parenthesis, and it's going to go on to infinity. Any questions on part O? Okay, let's move on to part P. So it says sketch graph the polynomial, state the zeros, y-intercepts, and end behavior. So this is where we're going to do the p's over q's. So let's look at number 2. So I have x to the 7th minus 3x to the 6th minus 9x to the 5th plus 27x to the 4th. So before we can do any of the p's over q's stuff, we need to make sure that everything's factored in common. So that x to the 4th, there's at least an x to the 4th in common with every x value. I'm going to adjust my mic here real quick. Sorry if it's noisy, because it's kind of hard to see the screen. And so then what I have left is going to be x to the 3rd minus 3x squared minus 9x to 9 sine x, and then plus 27. Then from there, I can do my p's over q's. So the factors of 27, which are 1, 3, 9, and 27, over the factors of 1. So that's going to be 1, 3, 9, and 27, because 1 over 1, 3 over 1, 9 over 1, etc., etc. They're all plus or minus. I'm not going to write them all, but they're all plus or minus. Now I need to go through and test it. Now, me just looking at this, because I notice that it's growing by 3s, right? 3 times 3 is 9, times 9 gives me 27. Maybe starting with a 3 might be beneficial. So let's try positive 3. So we write the coefficients, so 1, negative 3, negative 9, and 27. Now, if there were any gaps, if there were anything that was like missing, then we have to put a placeholder. Like, let's say the x squared didn't exist. We would have to put a placeholder of 0 there. So add straight down, multiply, add, multiply, add, multiply, and it worked. Nice. So rewriting what this is, I have x minus 3, because that was the 0 that I picked. So it's always x minus your 0. And then this is remainder constant x squared. So x squared minus 9. So x minus 3, x minus 3, and then x plus 3. Because the x squared minus 9 is going to factor into x minus 3 and x plus 3. So now we can rewrite what we have. So I have x to the 4th, x minus 3 squared, and then x plus 3. So I factored the polynomial. Because once it's factored, I just want to make sure. Let me double check here. Yep, 0 is y-intercept and end behavior. So, a few things. We can look at the original problem to help us determine what the end behavior is going to look like and the y-intercept. So we look at the leading term. The leading term is positive and the degree is odd. So when the degree is odd and the leading term is positive, it's going to have this type of shape for the end behavior. Now that's the shape of it. So when I sketch my graph, I know it's going to start down here and it's going to end up here. The camera's backwards. Okay. So now, so that's my end behavior. So I have that piece. Now my zeros in multiplicity. So my zeros are going to be 0, because if I set that equal to 0, I get 0. It's going to be positive 3 and negative 3. Now the multiplicity is how many of those zeros you have. And the reason why we need to know the multiplicity is because the graph interacts with my 0 based upon the multiplicity. So because my multiplicity, so since I have 4 of these, it's going to be multiplicity 4. And I have 2 of these, so it's going to be multiplicity 2. And I have only 1 of these, so it's going to be multiplicity 1. When the multiplicity is even, it's going to bounce and return in the same direction. So it's going to go up to the 0, hit it, and then go and return. Or if it's coming from above, it's going to go to the 0 and hit it, and then it's going to go back the way it came. If the multiplicity is odd, then it's going to cross through it. It's just going to touch the 0 and then keep going. The last little piece is the y-intercept. The reason why it's easier to look at the original, because if you just plug in 0 for x, 0 minus 0 minus 0 plus 0, my y-intercept is just 0. So now piecing it all together. So my zeros are 0, I'll say -3 and +3. My in behavior, so my graph is going to start down here and it's going to end up there. So let's start down there with the in behavior. So we're going to go to my -3. At -3, my multiplicity was odd, so it's going to cross through. At 0, my multiplicity was even, so it's going to bounce. And then at 3, my multiplicity was even, so it's going to bounce. And so there's a sketch of my graph. Any questions on that one? Okay. Last area. Okay. So for this one, it is find the missing sides and angles and find the area. Okay. Whoops. Let me just copy and paste that. So this one is going to be the law of sines or law of cosines. And so the given information, I have angle, angle, side. So angle, angle, side is going to be the law of sines. So to find these missing values, so I'll just label this triangle A, B, and C. I don't know what side C is. I don't know what side B is. And to find angle C, I can do 180 minus 20 degrees minus 62 degrees. And so that's going to give us what, 98? So that's going to be 98 degrees. So then to find the missing sides, we use the law of sines, so it's going to be sine. Well, actually, I want to find the side, so I'm going to do B over sine B equals A over sine A. So the formula would be B over sine B equals A over sine A. And so now we just got to get B by itself. So B equals 40 sine 20 over sine 62. You enter that in your calculator. Beep, bop, boop. To find C, same thing. C over sine C equals A over sine A. And get C by itself and enter that into your calculator. Now I just want to point out the lesson so you can look at the area of the triangles. So if you guys go to lesson 42-1, that's where you can get all the different formulas. And so I lay it out to where, depending on how it is, like angle, side, angle, or angle, angle, side, if it's side, 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 or side, angle, side, we have all the different values. Now, the nice thing about this, though, is once you've found all the sides and angles, you could always use this one right here, which is the easiest one. Right? So if you find all the sides and angles here, technically this is all you have to worry about. I actually only memorized these two. Heron's theorem, and then the side angle side. 1/2 BC sine A. These are the two that I memorize. These are the only two you need to memorize. Because side, 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 it takes a lot longer to find the angles because you have to go through all the log cosine stuff. So to save your time, if you just know this, boom, you have it. But this is a more complicated theorem. You just find one piece of information here using the law of sines, and you can use this one. And using the law of sines, as we notice, that's not super complicated. So in this instance, all I have to do is just look at it where it's side, angle, side. So for example, I can do side, angle, side. Or if I want to use the actual B, C, and A from there, so we use angle A. So side, angle, side. Well, I know what my C is. We get it from this. I know what my B is. I get it from this. And I have my angle A. So you just do 1/2, whatever you got here, from B. Then whatever you get from C times the sine of A. And then you would get your area. So yeah, that was 42-1. Are there any last questions before I end the stream? Okay. Well, if there are any other questions, you can always reach out to me in Discord. More than happy to answer any issues that you have. Other than that, I hope we're safe. I hope we're healthy. The assignment is going to be up today in Google Classroom, so when you either finish Tuesday or Wednesday, you can go ahead and upload it. Wednesday is going to be the due date. That'll give me time to make sure I finalize everything and get all the grades uploaded and stuff like that into Aries, because the grades are due on Thursday. And that's the end. That kind of wraps our lessons here. So since we went through the entire, the worksheet, there will be no stream tomorrow, but I am available to answer any questions at any time. So I hope you guys are safe and healthy and are able to get everything just fine. Appreciate you guys, and have a good one.